The Soviet captain wasn't trying to escape. He was trying to become the torpedo. August 28, 1976, the Ionian Sea. The USS Voge is cutting through calm Mediterranean waters. 3,000 tons of American steel on a routine patrol. On deck, a poker game. In the galley, coffee brewing. Someone's telling a joke about shore leave in Naples. Nobody's watching the depth finder. 400 feet below them, hiding in the thermal layer where American sonar can't reach, something is waking up. The K-22, a Soviet Echo 2 class nuclear submarine, 2 football fields long, pregnant with cruise missiles, and its captain has just run out of patience. For 6 hours, the Americans have been tracking him, pinging, following, humiliating him in front of his crew. So he does something that will be studied in naval academies for the next 50 years. He orders battle stations, he angles the diving planes upward, and he pushes the throttle to full. On the Voge, the first sign is the coffee cup. It slides 3 inches across the mess table. Then the deck tilts. Someone laughs nervously, asks if they hit something. They did, or rather something hit them. The K-22 comes up like a breaching whale. 10,000 tons of Soviet steel meets American hull at a combined speed of 30 knots. The sound is indescribable. Sailors who survived compared it to a building falling on a car. The Voge is physically lifted from the water. Men are thrown into bulkheads. Bones break. For 11 seconds, someone counted the 2 vessels are locked together. A Soviet nuclear submarine trying to drag an American warship down into the Mediterranean. Then the K-22 tears free, rips a gash in the Voge's stern you could drive a truck through, and disappears back into the deep. The official report called it an accident. It wasn't. This was a tactic. And it was just the beginning. For 40 years, the Soviet Union faced a problem they couldn't solve with tanks, couldn't solve with missiles, couldn't solve with the largest standing army in human history. The American aircraft carrier. If you've never seen one in person, the statistics don't prepare you. A Nimitz-class carrier is a floating city. 90 aircraft, 6,000 crew. More firepower than most countries. It can park itself off your coastline and delete your capital from the map. And there's nothing your army can do about it because your army can't swim. For the Soviets, this wasn't a military problem. It was an existential one. Look at a map. The Soviet Union is a land empire. Vast, continental, built for tank warfare and artillery duels. Their navy was an afterthought, coastal defense force playing dress-up. The Americans? They owned the oceans. And in the Cold War, owning the oceans meant everything. Carrier strike groups could appear off Vladivostok, off Murmansk, off any coastline Moscow cared about. They traveled with a ring of steel destroyers, cruisers, attack subs. Anything that got within 200 miles died. Soviet planners ran the simulations again and again. Every scenario ended the same way. In World War III, the carriers would survive, and if the carriers survived, the Soviet Union burned. They tried building their own carriers. They were decades behind, and they knew it. They tried long-range bombers. The American F-14 Tomcats swatted them down like flies. The math was brutal. To guarantee one bomber reached a carrier, you had to launch 12. To launch 12, you needed the fuel, the pilots, the maintenance crews. It was unsustainable. So the generals went back to the Kremlin with a different request. We can't win fair. Let us fight dirty. We need something fast. Something that can dive deeper than their sensors reach. Something that can punch through the destroyer screen, get inside the ring of steel, and put a torpedo into that flight deck before the Americans know what's happening. We need a wolf. And if the wolf can't kill the prey with its teeth, the wolf becomes the weapon. What came out of the Soviet shipyards defied everything the West thought they knew about submarine construction. Project 705. NATO called it the Alfa class. The Americans built submarines like Cadillacs. Comfortable, reliable, room for the crew to breathe. The Soviets built something else entirely. They built a Formula One car with a nuclear reactor strapped to its spine. Rule 1 of submarine construction: you build the hull from steel. Steel is strong, steel is proven, steel has kept sailors alive since the Civil War. The Soviets threw out Rule 1. They built the Alfa from titanium. Titanium is stronger than steel and half the weight. I'll do. 2,000 feet, maybe deeper. Places where the pressure alone would kill anything that followed. But titanium doesn't weld like steel. Expose a titanium weld to oxygen, and it cracks. The entire seam fails. So the Soviets built airtight warehouses the size of aircraft hangars, pumped them full of argon gas, and dressed the welders like astronauts. Every shift was a moonwalk. Every whole section took months. The cost was astronomical. Engineers joked darkly, nervously, that it would have been cheaper to build the hull from solid gold. They called it the golden fish. The name stuck. But gold can't do what the Alfa did. Rule 2 of submarine construction. Nuclear reactors are cooled by water. Water is safe. Water is predictable. Water has worked since the Nautilus. The Soviets threw out Rule 2. Water-cooled reactors take hours to reach full power, hours to spin down. They're designed for patience, for stealth, for the long game. The Alfa wasn't built for patience. The engineers used liquid metal coolant, a lead bismuth alloy that flows like mercury and transfers heat like nothing else on Earth. This let the reactor generate insane power instantly. American sub needs for hours to go from cold start to full speed. The Alfa did it in 60 seconds, and the speed. An American Los Angeles-class sub tops out around 30 knots. Fast for a submarine. Respectable? The Alfa could hit 41 knots, 47 miles per hour, underwater. That doesn't sound like much until you understand what it means in combat. The standard American torpedo, the Mark 48, had a top speed of around 40 knots. The Alfa could outrun it. Let that sink in. You're an American sonar operator. You've found the enemy. You've fired your weapon. You watch the torpedo track toward the target. The target just accelerates, pulls away, leaves your million-dollar weapon flailing in its wake. Then it turns around and comes for you. But what's the point of a submarine that can outrun torpedoes if it's still stuck playing defense? The Soviets weren't interested in defense. The Alfa doctrine was simple. Detect, sprint, and kill. Now, here's how it was supposed to work. Soviet reconnaissance satellites spot an American carrier group in the North Atlantic. Position is relayed to Northern Fleet Headquarters. Headquarters contacts the Alfa on patrol. The Alfa doesn't creep toward the target, it doesn't sneak. It runs, 41 knots, straight at the carrier group, closing the distance at almost 50 miles per hour. Now, at that speed, the Alfa is loud. Screaming loud? Every sonar array within 100 miles can hear it coming. But here's the thing. Knowing something is coming and stopping it are two very different problems. The American destroyers fire their torpedoes. The Alfa dives 2,000 feet into the black, where the pressure makes the American weapons unreliable, or it just outruns them. The torpedoes exhaust their fuel. The Alfa keeps coming. By the time the destroyers reload, the Alfa is inside the perimeter. It's inside the ring of steel. At close range, the escorts have a problem. You can't fire without risking the carrier itself. The geometry turns against them. The Alfa is carrying a payload designed for exactly this moment. But here's where the doctrine gets dark. What if the torpedoes miss? What if the Alfa fires everything it has, and the carrier is still floating? Soviet naval intelligence knew something that kept American admirals awake at night. The Alfa wasn't just a weapons platform. The Alfa was the weapon. 3,000 tons of titanium moving at 45 miles per hour is not a submarine anymore. It's a missile. Aim it at the propellers. Aim it at the rudder. A carrier can survive a torpedo hit, cannot survive losing its ability to steer. Defector reports suggested that in a hot war scenario, if the captain couldn't get a firing solution, his final order was simple. ram. Take the reactor critical if you have to. Kill the engines on the target. Trade the wolf for the whale. They had a name for these maneuvers. Training exercises, where submarines practiced approaching targets at ramming speed, practiced the angles, practiced the final dive. The Americans called it something else. Crazy Ivan. Here's a story the Navy doesn't like to tell. June 1970. The Barents Sea. The USS Tautog, an American attack sub, is trailing a Soviet Echo class at close range. Standard shadow operation. Stay behind the target, in the blind spot where their sonar can't see you, and collect intelligence. The Soviet captain knows the game. He's been playing it for days. He's decided to change the rules. Without warning, the Echo throws its rudder hard over. Full reversal. The entire submarine pivots and comes screaming back toward its own wake. Toward the Tautog. The American captain has seconds to react. Seconds to realize what's happening. He orders an emergency dive. Too late. The collision is catastrophic. The Echo's propeller slashes across the Tautog's sail. Steel screams. The American sub drops like a stone. Flooding, crew scrambling, damage control fighting to keep the ocean out. Both submarines survive. Barely. The Tautog limps back to Pearl Harbor. The Navy classifies the incident, but the message was received. This wasn't an accident. This was a demonstration. Follow us, and we will turn and kill you, even if it kills us too. And the Crazy Ivan became standard Soviet doctrine. Every American sub-captain learned to keep distance, learned to watch for the sudden turn, learned that the enemy might decide at any moment that a mutual kill was an acceptable outcome. The Soviets were weaponizing their own holes. Now here's the part the Soviet recruitment posters left out. The Golden Fish was a death trap. It's not because of the Americans. The Americans barely had a chance to kill an Alpha. No, the Alpha killed its own crews just fine. Remember that liquid metal reactor? The miracle technology that gave them speed the Americans couldn't match? It had a design flaw. The lead bismuth coolant had to stay hot, always. 250 degrees Fahrenheit, minimum. Let the temperature drop, and the liquid metal stops being liquid. It freezes. And once it freezes inside the pipes, inside the reactor, inside the pumps, the submarine is dead, not damaged, dead. You cannot unfreeze a liquid metal reactor. Cannot chip the coolant out. You abandon the boat. This meant the Alpha could never turn off its engine. Ever. In port, they ran steam lines from the pier to keep the reactor hot. If the shore power failed, and this was the Soviet Union, so shore power failed, the reactor had to keep running. Engineers standing watch around the clock, monitoring temperatures, watching for the freeze. The crews called it babysitting the devil. And then there were the leaks. Water-cooled reactors leak sometimes. You get wet, you patch the pipe, you move on. When a liquid metal reactor leaks, you get a spray of radioactive lead bismuth that's hot enough to burn through skin and then it hits the air and solidifies instantly. Freezes into jagged metallic shrapnel, still radioactive, still 200 degrees. In 1982, the K-123 suffered a major coolant leak. The liquid metal flooded the reactor compartment, coated everything. The crew managed to surface, managed to get the hatches open, managed to survive, but the submarine was finished. It took 8 years to chip the frozen metal out of the hull. Some sections they just cut away and replaced. The radiation exposure wasn't discussed. Crew of the K-123 didn't discuss it either. Many of them couldn't. They were dead within a decade. Cancer, organ failure, the quiet casualties of the Golden Fish. And it wasn't just the reactor. The Alpha's automation systems were cutting edge. It had to be the sub only carried 30 crew members, a skeleton staff compared to American boats with over 100. Computers controlled the diving planes, the ballast, the reactor output. When the computers worked, it was elegant. When they didn't, it was terrifying. Systems would glitch. Diving planes would lock in the down position. Ballast would vent without warning. The crew joked when they joked at all that the submarine was trying to kill them. They weren't wrong. The Alpha was a glass cannon, the fastest, deepest diving, most theoretically terrifying weapon in the Soviet arsenal. And sitting inside one was a slow-motion death sentence. But here's the thing. The Americans didn't know that. The Americans saw the speed, the depth capability, the insane aggression of the doctrine. They didn't see the frozen reactors, the irradiated crews, the midnight maintenance emergencies. All they saw was a ghost that could appear from nowhere, outrun everything they could throw at it, and smash through their defenses like they weren't there. The fear alone was a weapon. U.S. Navy spent billions developing new torpedoes just to catch the Alfa, the Mark 48. A DCAP was designed specifically to outrun a sub that could outrun the original Mark 48. New sonar arrays, new tracking buoys, new doctrine. The Soviets had built a monster that barely worked, and it terrified the most powerful navy on Earth. By the late 1980s, the game was over. Not because anyone won, because one side went bankrupt. The Soviet economy was collapsing. The maintenance required to keep the liquid metal submarines alive, the constant heating. The specialized crews, the argon-filled repair facilities, was unsustainable. One by one, the golden fish were retired. Some had their reactors properly decommissioned. Most didn't. The Navy simply let the lead bismuth freeze solid, entombing the radioactive core in its own coolant, and towed the hulls to the scrapyards. They sit there still, rusting in harbors near Murmansk. The titanium that cost more than gold being stripped and sold for scrap. The reactor compartments sealed waiting. The era of the underwater dragster was over. Modern submarines went back to being quiet, patient, invisible. The doctrine of speed and aggression died with the Soviet Union, but the legacy and the cost that remains. In 2012, a Norwegian research team sent a submersible into the Kara Sea. They were looking for dumped nuclear material, Cold War leftovers. They found more than they expected. The reactor compartment of the K-27 sits on the seafloor at 30 meters depth. Not decommissioned, not sealed, just dumped. The lead bismuth core still inside. Samples showed elevated radiation levels in the surrounding sediment. The seals are degrading. Slowly, steadily, the kamikaze submarines are leaking into the Arctic food chain. The Russian government says they'll raise it eventually, secure it properly. They've been saying that for 20 years. Meanwhile, the fish keep swimming, the currents keep flowing, and the suicide machines keep killing just very, very slowly. Here's the question that historians still argue about. What if the Cold War had gone hot? Picture it. The North Atlantic. 1985. Soviet satellites spot the USS Nimitz battle group heading toward the Norwegian Sea. The order goes out. The Alfa on patrol receives its targeting data. 41 knots. Reactor screaming. Crew of 30 men who know they probably won't survive the hour. The American destroyers detect the contact. Fire everything. Watch their torpedoes fall behind. The Alfa crashes through the perimeter. Fires its weapons. Misses. And now the captain has a choice. Turn back. Save his crew. Accept defeat. Or keep the throttle pinned. Aim for the screws. Trade his life, trade all their lives for the chance to cripple the most powerful warship ever built. We'll never know what he would have chosen. We'll never know how many Soviet captains had already made that choice in their minds, waiting for the order that never came. And honestly, that's probably for the best. Some questions are better left in the dark. Some machines are better left forgotten. But history doesn't forget, and neither should we. Because somewhere right now, someone is designing the next weapon that asks its operators to die. The next machine that blurs the line between sacrifice and suicide. The next desperate gamble by a nation that knows it can't win fair. The Alfa is gone. The doctrine isn't. Watch your six.